Lesson 1-8, Commutative and Associative Properties. And in this lesson, you'll recognize and use the commutative and associative properties to simplify expressions. Let's take a look at this real-world application. Maps. The map below shows the location of Leticia's house and school. It also shows the time in minutes that it takes Leticia to walk around her neighborhood. Okay, and study that map for a few seconds. This is Leticia's house, obviously. Okay, and this is school, and these are the ways she goes to school, and so on and so forth. Okay, yesterday Leticia walked to school by way of Lincoln Street and Washington Avenue. She took 3 plus 3 plus 3 plus 2 plus 2 plus 2, or 15 minutes to walk to school. Today, Leticia walked to school by way of Madison Avenue and Wilson Street. She took 2 plus 2 plus 2 plus 3 plus 3 plus 3, or 15 minutes as well. The time it took Leticia to walk to school is the same for both days. Therefore, we can say that 3 plus 3 plus 3 plus 2 plus 2 plus 2 is equal to 2 plus 2 plus 2 plus 3 plus 3 plus 3. That's a lot of 3's and 2's. Okay, which brings us, okay, this particular example brings us to this particular paragraph, which says that in this equation the addends are the same. When we talk about addends, the addends are the numbers that you add together, which will end up with a sum. Okay, but their order is different. So the commutative property says that the order in which you add or multiply two numbers does not change their sum or their product. So what it's saying is this: you have A plus B is the same as B plus A, okay? And A times B is equal to B times A. Okay, this is the commutative property for both addition and multiplication. Okay, what do you notice also about the commutative property is that the order changes. From A plus B becomes B plus A times B becomes B times A. The order of the numbers change. Okay, so in this case, okay, order changes. And from what we learned in 6th grade, the root word of commutative is to commute. So when you talk about the commutative property, okay, you're talking about the word commute, which means to move. Okay, so you're moving the numbers around, and that's why the order changes. Okay, and if you also notice in the commutative property, there is no addition, there is no subtraction, nor is there division, because the commutative property only works for addition and multiplication. Okay, what do I mean by that? If I do 3 plus 5, this is the same as 5 plus 3, right? Both of them will equal to 8. If I do 2 times 3, that's the same as 3 times 2. Both of them will be equal to 6. But if I do 3 minus 5, it's not the same as 5 minus 3. Okay? And if I do 4 divided by 2, it's not the same as 2 divided by 4. So the commutative property does not work for subtraction, and it does not work for division, and that's the same with the next property. And in the next property, one easy way to find the sum or product of numbers is to group or to associate the numbers. Okay, that's why we come up with a associative property, which simply says that the way you group three numbers when adding or multiplying does not change their sum or their product. And this is the associative property of addition and multiplication for any numbers a, b, and c. The quantity a plus b closed quantity plus C is equal to A plus the quantity B plus C, and in multiplication, the quantity A times B times C is equal to A times the quantity B times C. Okay. Now also notice in the associative property, okay, in the commutative property, the order changes. In the associative property, the order does not change. Look at this: A, B, C, A, B, C. So the order of the numbers do not change in the associative property, but in the commutative property they change. So in this case, order does not change. Okay? So you can group 11 plus 12 plus 7 plus 9 plus 7 plus 6 to make mental addition easy. And how do you do that? Let's find out. Okay? So we'll have 11 plus 12 plus 7 plus 9 plus 7 plus 6 will be equal to 11 plus 9 plus 7 plus 6 plus 7 plus 12 using the commutative property of addition. You're moving the numbers around. Why are we moving it this way? Because we know that it's easier to add 11 plus 9. That'll become, okay, group that. And if you group 7 plus 6 plus 7, okay, again, that's easier to add. 11 plus 9 becomes 20. Okay, and this becomes 20, and you add 12 as well, so you end up with 52. Okay, so the commutative and associative properties can be used with the other properties that you've studied when evaluating and simplifying expressions. Okay, let's take a look at example number 1. Not that one, example number 1. Juan Martinez is a product manager for a cereal company. Part of his job is to determine what size box should be used to package the company's toasty Oatses cereal. One can choose from among the following sizes: 8 by 11 by 2 and 1/2, 8 by 1/2 by 10 by 2, or 7 and 7/8 by 11 by 3. One wants to know which package will hold the most cereal. We'll be basically talking about the volume of each box. The box with the greatest volume will hold the most cereal. To find the volume of each box, multiply the length times the width times the height. Remember the formula for volume. In 7th grade, we talked about volume as being big B times H, where big B represents the area of the base. And in this case, the area is a rectangle. That's why the area of the base is length times width times height, and that's exactly what we have here. Okay, so moving on, we now have the 8 times 11 times 2 and 1/2. 8 by 2 and 1/2 times 11 using the commutative property. Okay, we moved 2 and 1/2 and 11. Okay, and then we know that it becomes 20 times 11 because 2 and 1/2 times 8 will give you 20, and multiply that by 11. 20 and 8 times 2 and 1/2 has been substituted by 20. That's why you use the substitution property of equality. And again, the substitution property of equality, we end up with 220. So the volume of the first box, okay, would be 220 cubic inches. Okay, so let's look at the dimensions of the second box. We have 8 and 1/2 times 10 times 2. Okay, using the commutative property of multiplication, we switch 2 and 10 around, so we end up with 17 times 10, because 8 and 1/2 times 2 will give you 17, using the substitution property of equality, which is the same as 170. So the volume of the second box is 170 cubic inches. And let's consider the last box, 7 and 7/8 times 11 times 3. Using the associative property, we simply group 11 times 3. And we know that 11 times 3 is 33. Using the substitution property of equality, you now have 7 and 7/8 times 33, multiply the two numbers, you end up with 63 times 8 times 33, which is the improper fraction of 7 and 7/8, 63 over 8 that is. And simply put, it's 259 and 7/8. The volume of this box has the greatest value of 259 and 7/8 cubic inches. Okay? And finally, let's summarize the properties that we have learned. Okay? The chart below summarizes the properties you can use to simplify expression and the commutative property. Okay? You can there's addition and there is multiplication. Okay? Associative property as well, addition and multiplication. Okay? Identity property, anything you multiply or anything you add with 0 will still be the same number, and anything you multiply with 1 will still be the same number. The zero product property, simply it works for multiplication. Anything you multiply with 0 will always be 0. The distributive property works for both addition and multiplication, and it also works for subtraction. And finally, the substitution property works for addition and multiplication as well. Okay? And let's finish this off with example number 2. Write an algebraic expression for the verbal expression: the sum of 2 and the square of t increased by the sum of t squared and 3. Okay, and letter B, then simplify the algebraic expression indicating all of the properties used. So, in letter A, the sum of 2 and the square of t will be 2 plus t squared. Okay, increased by the sum of t squared and 3. Increased by, which is indicated by a plus sign, the sum of t squared and 3. Okay, so that will be your algebraic expression. Combine them, 2 plus t squared plus t squared plus 3. Okay, using the commutative property of addition, we put the two t squareds together and 2 plus t together. Why? Because t squared and t squared are like terms. 2 and 3 are also like terms. Use the associative property to group them. Okay, and then we simply add or let's do another step. The multiplicative identity, which simply states that the coefficient of t squared is 1. Okay, and then that's how we can add them together using the distributive property. You end up with 2t squared plus 5. This now becomes your substitution property. And this is how you simplify this expression right there. Alrighty then, we're done with this lesson, and on Google Forms, write a summary of what you've learned by responding to the objectives of this lesson. Type a question you might want to ask about this lesson. Thank you.